This lesson is about the explicit formula for geometric sequences. Remember that a geometric sequence multiplies or divides by the same number each time. So the formula an equals a1 times r to the power of n minus 1, where a1 is the first term of the sequence, or first number, and r is the common ratio, or the number that it's multiplying by each time. If I want to write the formula for a sequence, I have to be able to find the first number and also what it's multiplying by. If we have the sequence 7, 35, 175, etc., the first number is 7, and if we divide, we can see that it's multiplying by 5 each time, so the common ratio is 5. If we plug those numbers into the formula, we get an equals 7 times 5 to the power of n minus 1, since the formula starts at 7 and then multiplies by 5 each time. If I already know the formula and I want to find specific terms, I would just plug in the number for the term I'm looking for. So if I want to find the first 3 terms, I would plug in 1, 2, and 3. To get the first term, I plug in 1 for n. So a1, which means first term, equals 5 times 2 to the 1 minus 1, which is 5. To get the second term, I would plug in 2 for n. a2, which means second term, equals 5 times 2 to the power of 2 minus 1. This equals 10. The third term, we would plug in n equals 3, so we would get a3, which means the third term, equals 5 times 2 to the power of 3 minus 1, which equals 20. So our first 3 terms are 5, 10, and 20. I can find any specific term that I want to. So if I wanted to find the 15th term, and I had 192, 48, and 12 as the first 3 terms, I would first write the formula by identifying the first term and the common difference. Since this sequence starts with 192 and divides by 4 each time, our formula is going to be that an equals 192 times 1/4 to the power of n minus 1. We would plug in 15 for n to find the 15th term. This gives us a very, very small number. So the calculator gave it to us in scientific notation, 7.15 times 10 to the negative 7. If you wanted to write that in standard notation, that would be 0.000000715, very small decimal. Remember, geometric sequences get very large or very small very quickly.